Curvilinear coordinate systems 14. An orthogonal UVZ coordinate system is defined by the following set of equations that relate these coordinates to a standard Cartesian set. And we have already done part D, which is invert the above expressions and solve for x and y in terms of u and b. And we came up with this set of equations. Now part E, express the position and displacement vectors in this system. Now the position vector is r, position vector, is normally given as x ex hat using Cartesian coordinates plus y ey hat plus z ez hat. But instead of doing it this way, I'm going to substitute for x what I have here, and for y minus v over u square plus v square, and z is equal to z. So let's do that. We have u over u square plus v square ex hat. So this is u over u square plus v square ex hat. And for y, we have minus v over u square plus v square. So we can write minus v over u square plus v square ey hat. And then we have z ez hat. This is our position vector. Now what I'm going to need is the scale factors h sub u and h sub v. For that I will need the partial derivative of the position vector r with respect to u. The derivative of u with respect to u is 1 multiplied by the bottom is going to give us u square plus v square minus the derivative of the bottom, which is 2u multiplied by the top will give us minus 2u square, and the bottom, which is u square plus v square parentheses square in ex hat direction. This will be the first term. Now I'm taking a derivative with respect to u of this term. The derivative of the top is 0 multiplied by u square plus v square, which will give me 0, minus the derivative of the bottom will give me minus 2u. Because of this minus sign here will become plus. So minus, I will have the derivative of the bottom minus 2u multiplied by the top v, u square plus v square square parentheses square ey hat. And there is no contribution from the z part. And similarly, if I do the derivative with respect to v, del r del v, I will have derivative of the top 0 multiplied by the bottom minus the derivative of the bottom, which is 2v multiplied by the top. So we're going to get minus 2uv on top divided by the bottom squared, u square plus v square squared in ex hat direction. And then for the second term, the derivative with respect to v of the top is 1 multiplied by the bottom is u square plus v square. So we will obtain minus u square plus v square, and minus the derivative of the bottom, 2v multiplied by the top will give me 2v square, minus 2v square divided by u square plus v square parentheses squared in ey hat direction. So I have determined the derivatives, partial derivatives with respect to u and v. So let's see if I can simplify this, so you can see that I have u square and minus 2u square. So this will give me v square minus u square. And for this term will remain the same. Also, this term will remain the same. Here I have u square minus v square with a minus sign, which will also give me a v square minus u square for this term. So let me rewrite the simplified forms. So del r del u is equal to with this simplification, I have v square minus u square divided by u square plus v square parentheses square in ex hat direction plus 2uv divided by u square plus v square parentheses square in ey hat direction. So that is my del r del u. So if I double check here, I will get v square minus u square, and here I will have the two minus signs canceling, giving me a plus 2uv over u square plus v square square in ey hat direction. And similarly, I can write the del r del v term. So let's do that here. The del r del v derivative. Here I have minus 2uv over u square v square squared, parentheses squared. So minus 2uv divided by u square plus v square parentheses squared in ex hat direction. And then I have the other term, this term here. This will give me v square, u square minus v square, but I have a minus sign, so this will become v square minus u square plus v square minus u square divided by u square plus v square squared, and that's in ey hat direction. Okay, so let's have these come closer to this side. So this is in ey hat direction for clarity. Okay, now I can take the magnitudes of these two vectors to find the scale factors. H sub u, so let me take this downstairs. H sub u, the scale factor, is the magnitude of del r del u. So let's take the magnitude of this vector, which means I have to take the x component squared and plus add to it y component squared, and then take the square root. So you can see that I will obtain v square minus u square parentheses square plus 4u square v square divided by, they have a common denominator, u square plus v square to the fourth power, and this is all inside the square root. Okay, and when I open this up, I'm going to get v to the fourth power minus 2u square v square plus u to the fourth power plus 4u square v square. This is divided by u square plus v squared to the fourth power, and that's all inside the square root. Okay, and now I see that I have a 4u square v square and a minus 2u square v square, so this will be 2u square v square. So if it's u to the fourth power plus 2u square v square plus v to the fourth power, that would be u square v plus v squared's square. So I can see that this scale factor h sub u is equal to v square, v to the fourth power plus 2u square v square plus u to the fourth power divided by u square plus v square to the fourth power. This is all inside the square root. And the top I recognize as being u square plus v square parentheses square. And this is divided by u square plus v square parentheses to the fourth power. And I have to take the square root of this. So this will give me, you can see that this one will cancel and make this 2, and square root of that is 1 over u square plus v square. So I can see that the scale factor h sub u is equal to 1 over u square plus v square. So that's what I find. Now, as for the scale factor h sub v, similarly, I have to take the magnitude of del r del v. And now I'm looking at del r del v. So this is going to give me 4u square v square plus v square minus u square parentheses squared divided by the bottom to the fourth power, u square plus v square to the fourth power. So this will give me, once again, v square minus u square parentheses square plus 4u square v square divided by u square plus v square to the fourth power, and then I'm taking the square root. Now take a look at this, what I have here and what I have done here. So these are identical. Therefore, I conclude that the scale factor h sub v is equal to the scale factor h sub u, which is 1 over u square plus v square. And since I have z is equal to z, the scale factor h sub z is equal to 1. So once I know these scale factors, I can calculate the unit vectors. What is the unit vector EU hat? This is 1 over the scale factor h sub u del r del u. So del r del u divided by its magnitude. And this gives me, for EU hat, I'm looking at del r del u, which is this guy, and I'm dividing it by 1 over u square plus v square. So that means I'm multiplying both of these terms with u square plus v square. One of the squares will cancel. Therefore, I will have EU hat is equal to, for the x component, v square minus u square divided by u square plus v square. And now I don't need the parentheses anymore since I'm not squaring it. In EX hat direction. And then looking at the Y component, 2UV over plus 2UV over U square plus V square in EY hat direction. And similarly, I can calculate the unit vector EV hat, which is 1 over the scale factor H sub V del R del V. And once again, dividing it by the scale factor H sub V means I'm multiplying this with U square plus V square. So one of these will disappear. Therefore, my unit vector will be E sub V hat will be minus 2UV divided by U square plus V square in EX hat direction, and then V square minus U square divided by U square plus V square in EY hat direction. Basically, that is this guy multiplied with U square plus V square. So now I have my unit vectors. What else do I need? I need the components of the position vector in EU hat and EV hat direction. So what is the dot product R dot EU hat? So here is the position vector R. So I have to multiply the x components. U over U square plus V square will be multiplied with this V square minus U square over U square plus V square. So this would be U multiplied with that. So let's do that here. U multiplied with V square minus U square. And now I have identical terms at the bottom. So this would be squared. And then for the Y component, I have to multiply 2UV with minus V. So I will have minus 2UV squared divided by U square plus V square parentheses squared. Now you can see that I can take this into minus U parentheses. If I do that, I would be left with plus 2V. So minus U parentheses will give me plus 2V squared. And minus U parentheses would give me U squared minus V squared. So 2V squared minus V squared would give me V squared. So this is minus U parentheses U squared plus V squared divided by U squared plus V squared squared. So let me double check this. I have minus U cube minus UV squared is the second term here. This is plus UV squared minus 2UV squared is indeed minus UV squared. So this is correct. And now you can see that I have a cancellation of this, and this gives me, for the EU hat component, minus U divided by U square plus V square. All right. And now I have to look at the position vector's EV hat component. So position vector dot product with EV hat. This time I'm looking at this vector. Here is my minus 2UV that has to be multiplied with U. So I'm multiplying the x components. That gives me minus 2 U squared V divided by U square plus V square squared. And then I have to look at the Y components. V square minus U square must be multiplied with minus v. So here it is minus v multiplied with v square minus u square divided by u square plus v square parentheses squared. So that is the component of the position vector in EV hat direction. And when I take this into minus v parentheses, I have v square minus v square, u square, and minus v parentheses will give me plus 2u square. So 2u square minus u square will become u square plus v square. So this is once again equal to, in minus v parentheses, u square plus v square divided by the bottom u square plus v square squared. And once again, these will cancel, and I will be left with the EV hat component minus v over u square plus v square. All right, so now what I'm after is the position vector written in the new coordinate system. Position vector is r dot EU hat in EU hat direction plus r dot EV hat in EV hat direction plus r dot EZ hat in EZ hat direction. And now I have evaluated r dot EU hat. It was minus u over u square plus v square. So minus u over u square plus v square in EU hat direction. And the other one is minus v. So minus v over u square plus v square EV hat direction, and then I have z in EZ hat direction. That didn't change. So this is my answer for the position vector written in the new coordinate system. Now the displacement vector dr is the partial derivative of r with respect to u du plus the partial derivative of the position vector with respect to v dv plus the partial derivative of r with respect to z dz. And now you can see that because the unit vector was this divided by its magnitude, this is equal to hu du in EU hat direction. This is HV dV in EV hat direction, and this is HZ dz in EZ hat direction. So all I have to do is substitute the scale factors. So my answer for the displacement vector dr is, because the scale factors were identical for u and v, 1 over u square plus v square in EU hat direction, and I have dv over u square plus v square in EV hat direction, and then I have scale factor z was 1 dz in EZ hat direction. So that gives me the answer that I'm looking for the position vector, displacement vector dr. Okay, so if I review what I have done here, first I have written the position vector x ex hat, y ey hat, z ez hat using these equations. Then I've taken the derivatives with respect to u and then the derivative with respect to v, and I found these two results, this one and this one. Then I've taken their magnitudes, which is square root of x squared plus y squared. So x component squared, y component squared. and square root. That's what I have done. And I have seen that for both of these, I get the same scale factor, 1 over u squared plus v squared. The unit vector EU hat is 1 over the scale factor HU, which is magnitude of del R del U, multiplied by del R del U. So that's what I have done here, and similarly for EB hat. Then I have to take the component of the position vector in EU hat direction. So take a dot product of this vector with the EU hat vector that I have obtained here. And the way to do that is basically we have to multiply the x components. So x component here is minus 2uv multiplied by u, and for EV hat. For EU hat, it's v squared minus u squared multiplied by u, and that's what I have here. And then 2uv multiplied by minus v, so that's what I have here. After the simplifications, I obtain minus u over u squared plus v squared, and for EV hat, I obtain minus v over u squared plus v squared. The resulting position vector is EU hat component times EU hat, v component times EV hat, z component times EZ hat. That's written this way. And the displacement vector is partial derivative of r with respect to all of these coordinates multiplied by a differential change in the coordinates. And since this vector is simply the unit vector EU hat multiplied by HU, which means it's del R del U is HU EU hat. So let me remind you here, del R del U is HU EU hat, and simply also del R del V is equal to HV EV hat, and also del R del Z is HC EZ hat. And substituting the scale factor 1 over u squared plus v squared into this expression, I find the displacement vector in the new coordinate system.